In this video, I will introduce type 2 error, beta, and statistical power. The null hypothesis states that there is no relationship between our variables of interest. In reality, either the null hypothesis is true or it is not true. When we run our study, we then either decide that the null hypothesis should be rejected or we fail to reject the null hypothesis. So at the conclusion of our study, we have 4 possible outcomes. Either we correctly reject the null hypothesis, we correctly fail to reject the null hypothesis, we incorrectly reject the null hypothesis, or we incorrectly fail to reject the null hypothesis. Type 2 error is the case where in reality the null hypothesis is false, but in our study we fail to reject the null hypothesis as false. In statistics, we use the symbol beta to represent the probability of a type 2 error. More technically, beta is the probability of failing to reject the null hypothesis as false given a false null hypothesis in reality. Statistical power is calculated as 1 minus beta. Statistical power represents the probability of rejecting the null hypothesis as false given a false null hypothesis in reality. More simply put, power is the probability of correctly rejecting the null hypothesis. Statistical power is proportional to sample size. In other words, the more people in our study, the greater the probability of correctly rejecting the null hypothesis. Power is also proportional to the strength of the relationship between our variables. If there's a very strong relationship between our variables of interest, we have a greater probability of correctly rejecting the null hypothesis. Power is most commonly used at the outset of a study when we're trying to figure out how big of a sample size we need to recruit. For example, a scientist might ask, if in reality there's a certain size relationship between 2 variables, in other words, if in reality the null hypothesis is false, how many people do we need to have an 80% probability of correctly rejecting the null hypothesis?